Hey guys, my name is Wendy and today I'll be presenting a mini project on comparing a distribution to the normal model. So what is a normal model or bell curved graph? A normal model, also known as bell curved graph, is used to display a data that is unimodel and symmetric. A data with a mean of 24 and standard deviation of 2 can be written as n 24 2. And at the side, we see an example of a normal model or bell curved graph. Z-score. What is a z-score? Z-score indicates a data's value distance from its mean and are displayed using a normal model. It is used to provide a precise location of the score within a distribution. Empirical rule or 68, 95, 99.7. Empirical rule, also known as 68, 95, 99.7 rule, is a shorthand used to remember the percentage of value that lies within the interval estimate in the normal distribution. This rule expects 68% of the data value to fall within first standard deviation, 95% of the data value to fall within second standard deviation, and 99.7% of the data value to fall within the third standard deviation. So at the side, we can see the graph or like a bell curve shaped of an empirical rule or 68, 95, 99.7 rule. This is a normal graph or normal model that states our classmates' height in inches. So at the top left, you can see the mean of this class height in inches is 65.24 inches and standard deviation is 3.97 inches. And according to the empirical rule, the normal model states that 68% of this data should be in between 61.27 inches and 69.21 inches. 95% of the data should be in between 57.3 inches and 71.18 inches. And 99.7% should be in between 53.33 inches and 77.15 inches. And this is the actual distribution. So the actual distribution shows that 23 out of 33 or 67% falls under first standard deviation of the mean. 32 out of 33 or 97% falls under the second deviation of the mean. 33 out of 33 or 100% fall under the third standard deviation of the mean. So this is my final analysis. I say the normal model might not be a good estimate because, as you can see, although the data is unimodel, it is skewed to the right, which it breaks the imperial rule of 68, 95, 99.7. Because 67% of the height data falls under first standard deviation of the mean, 97% of the data falls under second standard deviation of the mean, 100% of the height falls under the third standard deviation of the mean. And that's it. Thank you for watching.